Imagine for a moment, drifting through the silent, infinite darkness of space. Stars scattered like diamonds. Galaxies swirling in a cosmic ballet. The universe stretches endlessly in every direction. Its mysteries beckoning us to wonder. How big is the universe? Is it simply vast, or is it truly infinite, beyond anything we can possibly imagine? Have you ever stared into the vast, inky blackness of the night sky and felt an overwhelming sense of your own insignificance? That feeling, so humbling, so profound, is just the beginning of a journey into the true, mind-bending scale of our universe. Tonight we invite you to let your imagination soar as we embark on an epic adventure through cosmic scale. Exploring the deepest universe secrets and confronting the mysteries of dark matter and dark energy. From the familiar comfort of Earth to the speculative frontiers of the multiverse, this space documentary will reveal astonishing facts about reality, astronomy, and cosmology. Facts that will forever change your understanding of human existence and our place beyond imagination. Along the way, we'll witness the birth and death of stars, the dance of galaxies, and the invisible forces that shape everything. If you're ready for a journey that will expand your mind and ignite your curiosity, hit that like button, leave a comment with your biggest cosmic question, and subscribe to the channel for more amazing space documentaries that push the boundaries of scientific discovery. The universe is not just a backdrop for our lives. It is a living, evolving story, written across billions of years and trillions of miles. Every question we ask, every discovery we make, brings us closer to understanding our place in this grand cosmic tapestry. The universe, as we understand it, is not merely large. It is incomprehensibly, staggeringly enormous, a vastness that defies even our boldest imagination. Our most advanced measurements, the tools and mathematics we wield to probe the cosmos, are but faint whispers against the true grandeur of reality. Distances are so extreme that light, the swiftest entity known, can only traverse a tiny fraction of the universe over billions of years. Galaxies themselves become mere flecks in a cosmic ocean, separated by gulfs so immense that their light takes eons to reach us. And here lies the profound paradox. What we can perceive, even with our most powerful telescopes, might be but a fleeting glimpse, a single drop in an endless, boundless sea of existence. The true scale of the universe is not just beyond our senses, but perhaps forever beyond our full comprehension. Every point of light in the night sky is a sun, many with their own planets. And yet between these islands of brilliance, there are unimaginable voids, stretches of emptiness so vast that even light, racing at 186,000 miles per second, seems to crawl. Our home galaxy, the Milky Way, is just one among billions, each spinning through the darkness, each separated by distances that stagger the mind. The further we look, the more we realize how little we can truly see. This documentary will guide you on an extraordinary journey, beginning from the familiar comfort of your own backyard and extending to the furthest frontiers of cosmic understanding. Along this path, we will uncover structures of such monumental scale that they render our entire galaxy into a mere speck of dust, lost in a tapestry of billions. We will explore the mind-bending possibility of an infinite universe, a concept that suggests the existence of countless versions of ourselves, each living out a different story in parallel realities. As we travel outward, you will witness how the universe's architecture grows ever more complex, from planets and stars to galaxies, clusters, and the vast cosmic web. By the culmination of this exploration, you will begin to comprehend why some of the most brilliant minds on Earth postulate that our reality might be embedded within something even more colossal and enigmatic than we have ever dared to conceive. Prepare to have your sense of scale transformed as we move from the known into the unknown, from the tangible to the truly unimaginable. The universe is not just bigger than we think, it is bigger than we can think. And as we journey together, you may find that the greatest mysteries are not just out there, but within our own capacity to wonder. Before we plunge into the cosmic abyss, a word of caution. This journey will challenge your perceptions in ways you may not anticipate. The numbers we encounter are so immense that mathematicians have devised entirely new notations to articulate them. The concepts are so bizarre that they often resemble the wildest science fiction, yet they represent the cold, unyielding reality of the universe we inhabit. If you have ever pondered your true significance, or if you yearn to experience the demolition and subsequent reconstruction of your entire worldview, then remain with us. For what you're about to learn will forever alter how you perceive everything, and may just ignite a sense of awe that lasts a lifetime. Let us begin our ascent from the familiar, from the very ground beneath your feet. Picture your hometown, the city or town you currently inhabit. It likely feels substantial, a sprawling expanse of streets, buildings, and countless lives. Every day, thousands, perhaps hundreds of thousands of individuals call it home, their daily routines weaving an intricate tapestry of human existence. The places you know, the parks, the schools, the markets, form the backdrop of your personal story. It feels real, important, a focal point of your universe. This is your immediate cosmic address, the starting point of our incredible journey through space and time, and the anchor of your identity in the vastness of existence. But your hometown is just one thread in a much larger fabric. Imagine a bustling city center, alive with movement and energy, each person living out their own unique story. The collective heartbeat of your community is echoed in cities and towns across your nation, each contributing to the greater whole. This sense of belonging, of being part of something larger, is the first step in understanding our place in the cosmos. Now let us gradually expand our perspective, zooming out just a fraction. Your entire nation, with its diverse cities, iconic landmarks, and millions of inhabitants, begins to shrink, transforming into a mere patch of land surrounded by the vast, indifferent expanse of oceans. The intricate details of your hometown, once so prominent, start to blur, becoming indistinguishable within the larger landscape. Borders fade, and the collective story of a nation emerges, a story of culture, history, and shared destiny. This widening perspective is crucial for understanding the true scale of the universe, as it reminds us how quickly the familiar can become small in the face of the vast. As we continue to zoom out, the nation itself becomes just a part of a continent, and then, with a little more distance, the entire planet comes into view. The boundaries that once seemed so significant dissolve, replaced by the singular fragile sphere we all share. This transition from the personal to the planetary is a humbling reminder of our shared home. Continue this outward trajectory, and Earth itself, our vibrant blue marble, recedes into the inky blackness of space, a solitary beacon in the cosmic void. At this scale, your hometown has vanished entirely, reduced to something less than a single pixel, an imperceptible detail in the grand cosmic tapestry. The continents, the oceans, even the entire planet become just another point of light among billions. Yet remarkably, we have barely begun our journey into the true scale of existence. The cosmic address continues, each step revealing a universe more immense and mysterious than the last. Our next stop on this cosmic ladder is our solar system. The Sun, a fiery orb of incandescent plasma, surrounded by its retinue of planets, moons, and a scattering of asteroids and comets. It appears at first glance to be a spacious domain, offering ample room for celestial dance. However, this perception is profoundly misleading. To truly grasp the emptiness of our solar system, consider this analogy. If our sun were reduced to the size of a basketball, placed at the center of a football field, Earth would be a mere grain of sand, positioned approximately 25 yards away. The outer reaches of our solar system, the distant realm of the Oort cloud, would extend roughly 4 miles from that basketball. 4 miles of almost entirely vacant space punctuated by a few scattered specks of cosmic dust. This, then, is our entire cosmic neighborhood, the cradle of all human existence, the stage upon which every life ever lived has unfolded. And even this seemingly vast expanse is so utterly minuscule that from the vantage point of the nearest star, it would be utterly invisible, a ghost in the cosmic expanse. This initial step highlights the immense astronomical distances we're about to explore, setting the stage for deeper space exploration and scientific discoveries. Now the true strangeness begins. That nearest star, Proxima Centauri, the one from which our entire solar system would be imperceptible, lies approximately 4 light-years away. But what does that truly mean? A light-year is not a measure of time, but of distance. It is the span that light, traveling at an astonishing 186,000 miles per second, covers in a single Earth year. In that time, light journeys nearly 6 trillion miles. So our closest stellar neighbor resides at a staggering distance of roughly 24 trillion miles. To put this into perspective, if you were to embark on a journey toward that star in a modern jet, it would take you over 5 million years. In a car at highway speeds, the trip would last an unimaginable 30 million years, far longer than the entire history of human civilization. And yet, this is merely the distance to our immediate stellar neighbor, a mere stone's throw in the grand cosmic ocean. Between stars, the void is so immense that even the largest planets are reduced to invisible specks, and the distances defy ordinary comprehension. The vastness between stars is the first hint of the universe's true scale. The emptiness between stars is so profound that, if our sun were the size of a basketball, Earth would be a tiny grain of sand 25 yards away, and Proxima Centauri would be another grain of sand over 4,000 miles distant. The scale is so vast that even beams of light, the fastest travelers in the universe, require years to bridge the gap. This immense separation is not unique to our solar system. It is the norm throughout the galaxy. The Milky Way is a sprawling city of stars, each separated by gulfs of darkness, each a sun with its own story. And yet, from afar, they blend into a luminous river across the night sky. Our home galaxy, the Milky Way, is a majestic spiral of cosmic grandeur, containing an estimated 200 to 400 billion stars. Most of these stars are separated by distances far greater than that to our nearest neighbor. The Milky Way itself stretches approximately 100,000 light-years across, a distance so immense that a beam of light, moving at the universe's speed limit, would take 100 millennia to traverse it from end to end. Imagine attempting to send a message to someone on the opposite side of our galaxy. It would take 100,000 years for that message to arrive, assuming, of course, that humanity still existed to receive it. Yet, here is the truly astonishing revelation. Our galaxy, the Milky Way, is not exceptional. It is neither remarkably large nor particularly small. It is in essence an average galaxy among the billions in the observable universe. This realization is a cornerstone of modern astronomy and cosmology, highlighting the immense diversity and scale of galaxies that populate the cosmos. There exist galaxies in the cosmos that dwarf the Milky Way, rendering it seemingly insignificant by comparison. Consider IC 1101, a colossal elliptical galaxy, approximately 50 times larger than our own, harboring an astounding 100 trillion stars. To put that number into perspective, it exceeds the total number of cells in your entire body. This single galaxy alone contains more stars than many smaller galaxy clusters. And this, remarkably, is still just the beginning of our journey into the universe's true scale. These immense structures are not isolated, they are part of larger groupings. Our own Milky Way, along with its closest galactic neighbors like Andromeda, forms what is known as the local group, a gravitationally bound collection of about 80 galaxies. This galactic neighborhood is a testament to the intricate dance of gravity on cosmic scales, a fundamental force shaping the cosmos and driving scientific discoveries. As we continue outward, the scale only grows more staggering, and the universe's grandeur becomes ever more humbling. Galaxies, far from being randomly scattered across the cosmic expanse, are intricately organized into even larger structures, groups and clusters. Our own Milky Way is part of the relatively modest local group, a collection of about 80 galaxies bound together by gravity. But this aggregation pales in comparison to the truly colossal galaxy clusters that populate the universe. The Coma cluster, for example, is home to over 1,000 galaxies, a bustling metropolis of stars, gas, and dark matter. The Perseus cluster boasts an even more impressive assembly, with more than 3,000 galaxies swirling within its gravitational embrace. These immense clusters are not isolated. They are bound together by the invisible forces of gravity and the enigmatic presence of dark matter, forming structures that stretch for hundreds of millions of light-years across the cosmos. Within these clusters, galaxies interact, merge, and sometimes collide, shaping their evolution over billions of years. Their sheer size and the number of galaxies they contain are a testament to the powerful organizing forces at play in the early universe and throughout cosmic evolution. And yet, even these vast clusters are just stepping stones to even grander cosmic structures. In the heart of these clusters, supermassive black holes and vast clouds of hot gas create environments of unimaginable energy. The gravitational pull within clusters is so strong that it bends light from distant galaxies, producing spectacular phenomena known as gravitational lensing. This effect allows astronomers to map the otherwise invisible dark matter that permeates these cosmic cities, revealing the hidden scaffolding of the universe. But the hierarchy of cosmic organization does not end there. These clusters in turn are interconnected, forming even grander structures known as superclusters. Our own galaxy is part of the Laniakea supercluster, an immense cosmic continent encompassing an estimated 100,000 galaxies, spread across a staggering 520 million light-years. Superclusters are the largest coherent structures in the universe, woven together by gravity and the mysterious influence of dark matter. To traverse this monumental structure, light itself would require over 500 million years. This means that light departing from one edge of our supercluster today would not reach the opposite edge until long after our Sun has exhausted its nuclear fuel and Earth has been reduced to cosmic dust. These superclusters are not isolated islands, but are connected by even larger filaments, forming a vast network that spans the observable universe. This incredible timescale underscores the profound astronomical distances and the vastness of cosmic time that define our reality. The boundaries of superclusters are not sharply defined. Instead, they blend into the cosmic web, a vast interconnected network of filaments and voids. These filaments, composed of galaxies, gas, and dark matter, stretch for hundreds of millions of light-years, linking superclusters together and shaping the large-scale structure of the universe. Yet, the universe reveals an even more intricate design. These superclusters are not isolated islands in space. They are linked by vast luminous filaments of galaxies and dark matter, forming an interconnected network that scientists refer to as the cosmic web. Imagine the largest, most intricate structure you can possibly conceive, and then envision it as merely a single thread within an unimaginably vast three-dimensional spiderweb that extends across the entirety of the observable universe. This cosmic web represents the universe's large-scale structure, a testament to the organizing power of gravity over billions of years. It is within this grand, interconnected framework that galaxies are born, evolve, and interact, painting a dynamic picture of the cosmos and driving continuous scientific discoveries in astronomy and cosmology. The cosmic web is the ultimate expression of the universe's interconnectedness, revealing that even the most distant galaxies are part of a vast, unified structure that binds the cosmos together. Having journeyed through the hierarchical structures of the cosmos, from our humble hometown to the grand cosmic web, we now turn our attention to the very fabric of space and time itself. When astronomers speak of the observable universe, they are not referring to the entirety of existence, but rather to the portion of the universe from which light has had sufficient time to reach us since the Big Bang. The edge of this observable sphere extends approximately 46.5 billion light-years in every direction from Earth, a distance that is almost unfathomable. This figure often sparks a fundamental question. If the universe is only about 13.8 billion years old, how can we possibly observe objects that are 46.5 billion light-years away? Shouldn't the limit of our vision be constrained by the age of the universe? The answer lies in the dynamic nature of space itself, which has been expanding relentlessly since the dawn of time, stretching the very fabric of reality and carrying distant galaxies ever farther from our vantage point. To visualize this, imagine the universe as a vast, ever-inflating balloon, with every point on its surface moving away from every other point. As space itself expands, the distances between galaxies grow, and the light traveling toward us is stretched along with it. This means that the most distant objects we can see today emitted their light billions of years ago, but the space between us and those objects has expanded so much that they are now much farther away than when their light began its journey. The observable universe, therefore, is not a static bubble, but a constantly evolving horizon, shaped by the interplay of light, time, and the relentless expansion of space. This apparent paradox unveils one of the most profound and counterintuitive aspects of our cosmos. The universe has been continuously expanding throughout its history. Light that began its journey toward us 13.8 billion years ago has been traversing an ever-stretching expanse. As this ancient light raced across the cosmos, the very space it occupied was simultaneously expanding, carrying its source further and further away from its initial position relative to us. By the time that light finally reaches our telescopes, the object that emitted it is now considerably more distant than it was when the light first embarked on its epic voyage. This dynamic expansion means that the observable universe is, in fact, a sphere roughly 93 billion light-years across, a colossal volume estimated to contain an astonishing 2 trillion galaxies. Each of these galaxies, in turn, potentially harbors hundreds of billions of stars, and each star, in turn, may host its own planetary systems. The sheer magnitude of these numbers is truly staggering, capable of making one's mind reel, underscoring the immense scale of the universe and the ongoing space exploration efforts to map it. And yet, beyond this observable limit, there may exist realms forever hidden from us, their light eternally out of reach, reminding us that our cosmic horizon is both a window and a boundary. This expansion, the very genesis of our universe, traces back to an event of unimaginable energy and density, the Big Bang. From a state of extreme heat and compression, the universe began its rapid expansion, a process that continues to this day. In the earliest moments, a phenomenon known as cosmic inflation propelled the universe's growth at a rate far exceeding the speed of light, transforming a subatomic realm into a cosmic expanse in less time than it takes light to cross a single proton. This inflationary epoch, though brief, laid the groundwork for the vast and intricate universe we observe, stretching the fabric of space-time and setting the stage for the formation of all subsequent structures. Understanding this initial burst of expansion is key to unlocking many universe secrets and is a central focus of modern cosmology and scientific discoveries. Even now, billions of years later, the universe continues to expand, with distant galaxies racing away from us at ever-increasing speeds. This ongoing expansion is not just a relic of the past, but an active process shaping the cosmos we observe today. The farther we look, the faster galaxies appear to recede, and some are already moving away so quickly that their light will never reach us. This means that the observable universe is not only vast but also ever-changing, with its boundaries slowly shifting as time marches on. Our cosmic horizon is both a testament to the universe's incredible history and a reminder of the mysteries that still lie beyond our reach. The accelerating expansion of the universe introduces a profound and somewhat unsettling concept: the cosmic horizon. This is not a physical barrier, a wall that one might encounter in space, but rather a fundamental limit to what we can ever know about the universe. Beyond this horizon, regions of space are receding from us at speeds greater than that of light. This means that any light emitted from these distant locales will never reach us, no matter how long we wait, no matter how advanced our technology becomes. As far as our observable reality is concerned, these places might as well not exist, for their events can never causally influence our own. The cosmic horizon is, in essence, the ultimate boundary of our knowledge, a moving frontier that defines the edge of the observable universe. It is a reminder that, no matter how powerful our telescopes become, there will always be regions forever hidden from our view, their stories eternally out of reach. This concept is a critical aspect of cosmology and highlights the boundaries of our current space exploration capabilities, challenging us to confront the limits of human curiosity. Consider the implications of this cosmic isolation. There could be civilizations in these unreachable regions, civilizations that have existed for trillions of years, developing technologies that would appear as magic to us. Entire galactic empires might have risen and fallen, their histories unfolding without our slightest awareness. We are, in essence, confined within a bubble of causality, surrounded by an infinity of events and phenomena with which we can never interact or even perceive. It is akin to being enclosed within a soundproof chamber, while an infinite orchestra performs an endless symphony just beyond our reach. The cosmic horizon is not just a physical limit, but a philosophical one. It forces us to accept that our knowledge of the universe will always be incomplete. The vastness beyond the horizon is a realm of pure speculation, where the laws of physics may play out in ways we cannot imagine, and where the story of the cosmos continues without us as witnesses. This profound thought challenges our understanding of human existence and our place in the grand scheme of things, reminding us that the universe is far larger and more mysterious than we can ever fully comprehend. And the unsettling truth is that this cosmic horizon is not static. It is, in fact, shrinking. Driven by the mysterious force of dark energy, the accelerating expansion of the universe means that galaxies visible to us today will, in the distant future, eventually recede beyond our cosmic horizon. Future civilizations, billions of years from now, will inhabit a far emptier universe than our own. They might gaze upon a sky devoid of distant galaxies, leading them to the erroneous conclusion that their own galaxy is an isolated island in a vast, dark cosmos, utterly unaware of the rich cosmic web that we are privileged to observe today. This raises a disquieting question. What are we, in our present moment, missing? What structures, what patterns, what cosmic phenomena exist just beyond the current limits of our observation? Are we, like those future astronomers, perceiving only a fragment of the grand cosmic reality? The answer almost certainly is yes. With every advancement in our observational capabilities, we uncover a universe more intricate and bizarre than previously imagined, a progression that shows no signs of abatement. The shrinking horizon is a cosmic clock, ticking away the time we have to witness the universe in its full splendor. It is a humbling reminder that our cosmic perspective is both precious and fleeting, and that the mysteries beyond our sight will forever beckon us to wonder. Speaking of the unseen, let us delve into the fundamental composition of our universe. At first glance, it may seem that the cosmos is made up almost entirely of the luminous entities we observe: stars, planets, galaxies, and the familiar matter that forms everything we can touch, see, and interact with. Yet this assumption is profoundly mistaken. All the ordinary matter, the atoms that make up our bodies, the air we breathe, the oceans, and even the most distant galaxies, accounts for less than 5% of the total mass-energy content of the universe. This means that everything we have ever known, every discovery in the history of science, is based on a mere sliver of reality. The vast majority of the universe is composed of components that are invisible and mysterious, eluding even our most advanced instruments. This startling revelation underscores the depth of our ignorance regarding the true nature of reality, and hints at the many universe secrets that remain to be uncovered. To visualize this, imagine a cosmic pie chart. The slice representing all stars, planets, and galaxies is barely a sliver, while the rest is dominated by two enigmatic components, dark matter and dark energy. These invisible elements shape the universe on the grandest scales, yet remain almost entirely beyond our direct perception. The realization that 95% of the cosmos is hidden from us is both humbling and awe-inspiring, reminding us that our journey of discovery has only just begun. Approximately 27% of the universe is composed of a mysterious substance known as dark matter. This enigmatic entity does not emit, absorb, or reflect light, rendering it invisible to our conventional telescopes. Its presence is inferred solely through its gravitational effects on visible matter. We observe its influence on the rotation of galaxies, preventing them from flying apart, and on the dynamics of galaxy clusters, holding these colossal structures together. Without dark matter, the universe as we know it would not exist. Galaxies would unravel, and cosmic structures would never have formed. Despite its pervasive gravitational pull, we remain utterly clueless as to its true identity. It does not interact with ordinary matter in any way we can currently detect, save for gravity, leaving its fundamental nature a profound cosmic puzzle. Scientists have proposed countless candidates for dark matter, from exotic particles to primordial black holes, but so far every attempt to directly detect it has come up empty. The search for dark matter is one of the most important quests in modern physics, and its discovery would revolutionize our understanding of the cosmos. Some of the most advanced experiments on Earth, deep underground detectors, powerful particle accelerators, and space-based observatories, are dedicated to unraveling the mystery of dark matter. Yet it remains elusive, a shadowy presence that shapes the universe from behind the scenes. Its gravitational fingerprint is everywhere, but its true nature continues to evade us, challenging the limits of human ingenuity and imagination. Even more perplexing is dark energy, which makes up a staggering 68% of the universe. This mysterious force is responsible for the accelerating expansion of space itself, literally pulling the universe apart at an ever-increasing rate. While we can measure its effects with remarkable precision, such as the way distant galaxies are receding from us faster and faster, its origin and fundamental properties remain an even deeper enigma than dark matter. We possess not the faintest clue as to what dark energy truly is or where it originates. Some theories suggest it is an inherent property of space, while others propose it is a dynamic field that evolves over time. Whatever its nature, dark energy dominates the fate of the cosmos, determining whether the universe will expand forever, slow down, or eventually tear itself apart in a dramatic finale. Thus, we find ourselves in a universe where a staggering 95% of its constituents are completely unknown to us. We are akin to ants attempting to comprehend the intricate workings of the internet. We can observe some of its manifestations, but the underlying nature of this reality remains fundamentally beyond our current grasp. As we continue to probe the cosmos, we may one day uncover the true identities of dark matter and dark energy, or we may discover that the universe holds even stranger secrets, challenging our very definitions of reality and pushing the boundaries of human understanding ever further. Having explored the vastness of our observable universe and grappled with the mysteries of its unseen components, we now venture into realms that push the boundaries of scientific inquiry and human imagination. Until now, we have discussed the universe as a singular, immense structure, a cosmic tapestry woven from every galaxy cluster, every supercluster, the entire cosmic web spanning 93 billion light-years. But what if this entire tapestry is merely one tiny bubble floating within a boundless ocean of infinite other universes? Welcome to the multiverse, a concept where the truly unimaginable begins to unfold, offering a glimpse into universe secrets far grander than we ever conceived. The multiverse hypothesis suggests that our universe is just one of an infinite ensemble, each universe a separate bubble with its own unique properties. Some may be similar to ours, while others could be governed by entirely different laws of physics, with alternate forms of matter, energy, and even time. In this cosmic foam, universes are born, expand, and sometimes fade away, never interacting with one another. yet collectively forming a structure of unimaginable scale. The very fabric of reality as we know it may be just a small patch in an endless quilt of existence. This is not the stuff of mere science fiction. It is a serious scientific hypothesis known as eternal inflation. According to this theory, the period immediately following the Big Bang was marked by an astonishingly rapid expansion, far exceeding the speed of light. But as our most advanced cosmological models suggest, this inflationary expansion never truly ceased everywhere. Instead, it only halted in specific regions such as our own observable universe, while continuing indefinitely in others. Each region where inflation eventually subsides gives rise to a distinct bubble universe, each possessing its own unique properties and physical laws. The multiverse concept also raises deep philosophical questions. If every possible version of reality exists somewhere, what does that mean for our sense of uniqueness, for the meaning of choice, or for the nature of existence itself? Are we just one of countless iterations, our lives playing out in endless variations across the infinite tapestry of the multiverse? Or does the very existence of these other universes enhance the wonder and preciousness of our own? This extends beyond mere personal variations. Imagine universes where the dinosaurs never faced extinction, where humanity evolved from an entirely different lineage, or where the entire historical trajectory of Earth unfolded in a fundamentally altered manner. There are universes where our solar system contains a different complement of planets, where our galaxy assumes an entirely distinct morphology, or where the cosmic web itself formed into radically different patterns. Yet the strangeness deepens further. In some of these universes, the fundamental constants of nature are so divergent that matter as we comprehend it simply cannot exist. Instead of atoms, there might be entirely novel forms of particles, governed by alien rules. Instead of chemistry, there might be processes so utterly foreign that our current conceptual frameworks are insufficient to describe them. Envision a universe where space possesses more than the 3 dimensions we perceive, or where time flows in reverse, or where multiple timelines coexist simultaneously. Imagine a universe where consciousness itself is a tangible physical force, where thoughts possess mass and dreams have the power to reshape reality. All these possibilities, and an infinite multitude of others beyond our current comprehension, would exist somewhere within the infinite expanse of the cosmic multiverse. Even as we grapple with the mind-boggling implications of the multiverse, our journey into the nature of reality continues to reveal even stranger possibilities. What if our entire universe, with its galaxies, dark energy, and cosmic horizons, is merely a projection, an illusion cast by a deeper, more fundamental reality? This brings us to the holographic principle, one of the most profound and unsettling ideas in modern physics. According to this theory, all the information contained within a volume of space can be entirely encoded on its boundary, much like a 3-dimensional image projected from a 2-dimensional surface. Imagine a hologram on a credit card. It appears 3-dimensional, yet all the information needed to create that image is stored on a flat plane. If the holographic principle holds true, then our perceived 3-dimensional reality might simply be a projection, a shadow cast by information encoded on a 2-dimensional surface at the very edge of the universe. Every experience you have ever had, every star you have ever gazed upon, every thought that has ever crossed your mind could be nothing more than patterns of information existing in fewer dimensions than you can possibly perceive. This concept challenges our fundamental understanding of existence, suggesting that the universe itself is a vast cosmic code, an intricate tapestry of data woven into the very fabric of space-time. Some physicists even propose that space and time themselves may emerge from this underlying information, hinting at a reality where the familiar rules of physics are mere byproducts of deeper, abstract principles. The holographic principle opens new avenues for scientific discovery, inviting us to rethink what it means to exist within the universe. But the rabbit hole of reality extends even further. Some theories propose that our universe is not a self-contained entity, but rather a membrane, a thin film or brain, floating within a higher dimensional space known as the bulk. These branes could occasionally collide, and each such cosmic impact might trigger a Big Bang, giving birth to an entirely new universe. Our entire reality, therefore, could be the serendipitous outcome of a cosmic fender bender in dimensions beyond our comprehension. Other models suggest an even more bizarre scenario, that our universe might actually exist within a black hole, itself residing in a higher dimensional universe. From our limited perspective, we observe an expanding cosmos originating from a Big Bang. Yet, from an external, higher dimensional viewpoint, we might simply be information spiraling into a black hole, stretched and distorted by its extreme gravitational fields. These mind-bending concepts push the boundaries of space exploration and theoretical physics, reminding us that the true fabric of reality may be far stranger than anything we can currently imagine. The simulation hypothesis has captured the imagination of scientists, philosophers, and the public alike. At its core, this idea suggests that everything we perceive, every star, every planet, every atom, and even our own consciousness, could be part of an incredibly sophisticated computer simulation, created by an advanced civilization far beyond our own. As computational power grows exponentially, it becomes conceivable that future civilizations could simulate entire universes, complete with sentient beings who are unaware of their artificial origins. If such simulations are possible, then the number of simulated realities could vastly outnumber the single base reality, making it statistically more likely that we ourselves are living inside a simulation. Imagine that every shimmering star, every distant galaxy, and every law of physics is nothing more than a line of code executed flawlessly by a cosmic supercomputer. Our memories, emotions, and even the passage of time could be programmed parameters, giving us the illusion of free will and continuity. The implications are profound and unsettling. If we are digital entities within a digital universe, then every experiment we conduct, every observation we make, could simply be part of the simulation's programming. There may be no definitive way to prove or disprove our simulated nature, as any evidence could itself be simulated. This leads to deep philosophical questions. If our reality is simulated, does it diminish the meaning of our experiences, or does it simply shift the context in which meaning is found? Are our emotions, relationships, and achievements any less real if they are the result of code rather than atoms? Some theorists even suggest that the search for the universe's deepest secrets, such as the nature of consciousness or the origin of physical laws, might ultimately reveal clues about the architecture of the simulation itself. Could the apparent mathematical order of the cosmos be evidence of an underlying code? Might glitches or anomalies in physics hint at the boundaries of our programmed reality? Ultimately, the simulation hypothesis forces us to confront the very nature of existence. Whether we are biological beings in a physical universe or digital minds in a simulated one, the mysteries of our reality remain as deep and awe-inspiring as ever. The question is not just whether we are real, but what it truly means to be real. Our journey began with a single question: how big is the universe? We started at home in the comfort of our own towns and cities, surrounded by the familiar rhythms of daily life. But as we zoomed out, our perspective shifted. Our hometown became a dot within a nation a patch on a continent, and our planet a fragile blue sphere adrift in the cosmic dark. From there we soared outward, past the moon and planets, through the vast emptiness of our solar system, and into the realm of stars. We witnessed the grandeur of the Milky Way, our home galaxy, one among billions, each a swirling city of stars separated by unimaginable distances. We explored clusters and superclusters, immense gatherings of galaxies bound by gravity, and traced the filaments of the cosmic web, the universe's vast scaffolding. At every scale, the numbers grew more staggering, the distances more humbling, and our place ever smaller. We reached the edge of the observable universe, a sphere 93 billion light-years across, containing trillions of galaxies, each with its own stars and worlds. Yet even this is not the end. We confronted the mysteries of dark matter and dark energy, invisible forces that shape the cosmos and drive its expansion. And beyond, we glimpsed the possibility of the multiverse, countless other universes, each with its own laws, forever beyond our reach. So how big is the universe? The answer is both scientific and philosophical. The observable universe is vast beyond comprehension, but the true universe may be infinite, or stranger still, its full extent forever hidden from us by the limits of light, time, and the boundaries of knowledge itself. In the end, the universe is as big as our curiosity, as deep as our questions, and as boundless as our imagination. We are small, but our wonder is infinite. Thanks for staying with us on this journey. Share your thoughts or biggest questions in the comments. We'd love to hear from you. If you enjoyed this space documentary, give it a like and subscribe for more adventures across space, time, and the mysteries beyond.